A small quantity of sodium containing Na24 radionuclide, half-life 15 hour, of activity 1 microcurie is injected into the blood of a person. A sample of the blood of volume 1 centimeter cube taken after 5 hours shows an activity of 296 disintegrations per minute. Determine the total volume of the blood in the body of the person. Assume that radioactive solution mixes uniformly in the blood of the person. So for this problem, we begin with the information that is given in the first part. So the half-life is given to us as 15 hours. So from here we can calculate the value of lambda, which is equal to 0.693 by t half. So we can write it as 0.693 by 15. So we are putting the time in hours, so kindly keep it in mind. Now initially it is saying that the initial activity of the injected sample, initial activity A0 of the whole sample is equal to 1 microcurie. So we can write it as 1 into 10 to the power minus 6 curie, and we can convert using this formulation to get the value equal to 3.7 into 10 to the power 4 disintegrations per second. Now the question is saying a sample of the blood of volume 1 centimeter cube is taken after 5 hours. So now we are saying on the observation sample. Now the sample is of volume 1 centimeter cube. This must be kept in mind. So the question is saying after 5 hours, so t equal to 5 hours, it is showing an activity of 296 disintegrations per minute. So we can say that AT is equal to 296 disintegrations per minute. So if we use the formulation AT is equal to A0 e to the power minus lambda t, so we can calculate the initial activity of 1 centimeter cube sample. So over here we are solving for A0. So we say that AT is equal to 296, which is equal to A0 e to the power minus 0.693 by 15, and since the time is in hour, we are putting 5 also in hour. So from here we obtain the value equal to A0, which is equal to 296 divided by e to the power minus 0.231, which is equal to 372.91, or we can write it as 373 disintegrations per minute. So now we are saying that the activity A0 can be written in terms of disintegrations per second by dividing it by 60. Now since we are talking about 1 centimeter cube of the blood, so the value of initial activity is coming out to be 373 by 60 disintegrations per second. So when we talk about the entire sample, so the initial value of the activity was given to us as 3.7 into 10 to the power 4 disintegrations per second. So using this, we are saying that 373 by 60 disintegrations per second is exhibited by 1 centimeter cube of blood sample. So the activity of 3.7 into 10 to the power 4 disintegrations per second will be shown by 3.7 into 10 to the power 4 into 1 by 373 into 60 centimeter cube of blood. So we divide by 1000 to obtain the answer in liters. So on solving, we obtain a value equal to 5.95 liters, which we can approximate as 6 liters of blood in the human body.